Good morning, everybody. And thank you very much for joining the webinar today. It's the 7th of our series on space satellite-based solutions for critical infrastructures. My name is Annalisa Donati, and I'm a new face in this series. I am the Secretary General of Eurisi. Eurisi is an association of space agencies. So at the moment, we gather 20 space agencies across Europe. And what we do collectively, it's basically find strategy and actions to promote the benefit of satellite-based application for different sectors, from mobility to critical infrastructure, from energy to climate change, from sport to culture and leisure. We hold the largest European database of user cases and success stories. So for everybody who's interested in getting to know a little bit more what space can do for society, you can just go and visit our website. We do organize this series together with our partner organization, Nereus, and Margherita is with me today, and I will give her the floor in a second. And just to introduce the session today, I wanted to say a couple of words in terms of the relevance of the topic of water management, wastewater management, as a critical infrastructure. I mean, we all know the challenges that we're facing nowadays with water scarcity and drought that are increasing, and how important is to effectively and efficiently manage our water resources. So this said, I just wanted to say that the directive that was proposed in December 2020 by the European Commission to enlarge the scope of the critical entities that we need to monitor and to maintain more effectively has been approved by the European Parliament 2 days ago. So now it is a European directive, and I mean, we are happy that basically we can showcase what our space and satellite infrastructure can do for this sector. So with no further delay, I want to pass the floor to Margherita. She will provide also some logistics about the day, and then we can kickstart our webinar.
Thank you very much, Annalisa. Very shortly from my side, to present the network. Nereus is the network of European regions using space technologies, and it's the only European association that represents the interests of European regions using space towards the European space community. And of course, our main mission is to promote the benefits of space technologies for European regions. You can pose your questions in the chat. Feel free to pose your questions in the chat. We are monitoring it constantly. If you have any problems with the connection, you can also send a message in the chat and we will figure out how to solve the problem. Otherwise, I would like also to wish you a very successful webinar and a fruitful discussion. Back to you, Annalisa. You're muted.
Yes, indeed. So thank you very much, Margherita, for the presentation. And so we wanted to start today by presenting a use case. So we do have with us Andrea Aliscioni, who is the director of the Metropolitana Milanese. And we want to basically present this case by having a first part, which is a video that we will showcase right now, which was part of the Copernicus for Region initiative promoted by Nereus, and that basically showcased how in Metropolitana Milanese is basically integrating satellite information into their workflow in order to better monitor the status of the water grid infrastructure in Milan. So before actually giving the floor to Andrea, I will showcase the video for everybody. So please tell me if you can hear the sound and it's everything good.
Copernicus data are increasingly being used by local and regional authorities across Europe. The 99 user stories contained in this book collectively testify how Copernicus provides solutions to address a wide range of challenges. There are many portraits showing how the system contributes to modernizing the public sector and deliver more efficient public services. For example, data from the Copernicus Sentinel-1 satellites are used to detect and monitor ground displacements that can potentially affect the stability of infrastructures. This story is about how Sentinel-1 data are used to support the management and the maintenance of the public sewerage network in Milano.
La nostra società gestisce, società completamente pubblica, gestisce l'intero ciclo idrico della città di Milano. Il nostro problema è quella di disporre di una piattaforma di early warning per avere in anticipo tutte le informazioni di situazioni anomale sulla nostra rete infrastrutturale sotterranea e ovviamente anche quella di agire in anticipo rispetto a situazioni di pericolo e di pubblica incolumità.
Thanks to the Copernicus satellite, it is possible to measure with a millimeter accuracy the ground movement above the water and sewer networks. What we do for Metropolitana Milanese is to detect directly the pipeline that need to be inspected with priority, and we provide not the data, but we provide directly the solution, because we highlight the pipeline that need to be inspected and providing different level of priority. And with this application, the customer is managing the maintenance activity and is able to prevent the risk, the collapse risk on their pipelines.
Per il futuro vogliamo estendere il progetto, la tecnologia, la soluzione satellitare provata e testata in modo efficace anche all'infrastruttura acquedotto, poiché eventuali perdite del sistema acquedotto si traducono anch'esse con una subsidenza, con uno svuotamento del terreno legato appunto alla perdita idrica, per cui facilmente identificabili da un passaggio satellitare e con la tecnologia radar ad apertura sintetica.
Milano is not the only place where Copernicus data are being used to monitor the stability of the terrain and support the management of public infrastructure. Other entities in Europe are starting to use data from the Copernicus Sentinel satellites for similar purposes. Discover how Copernicus data are being used by local and regional authorities in Europe.
So I take over again because today indeed we have with us Andrea that can provide us with an update on what Metropolitana Milanese is doing with those data and how Copernicus is indeed contributing to the monitoring of the whole infrastructure, water infrastructure grid in Milan. So Andrea, the floor is yours.
Hello, Annalisa. Thanks for the invitation. It's a good opportunity for us to share today our experience, the development of about the video you are sharing with us. It's an old video. It was registered in 2018, if I well remember. And now that solution showed it has become an established working tool. It's integrated part of our processes. Okay. Now I want to share a presentation. Only one moment. Okay. Let me know if you see the slides. It's okay?
Perfectly. Yes.
Okay. What's the purpose of the satellite monitoring is our sewage network, obviously, no? As shown in the video. It's a complex underground infrastructure, and the extension of our sewer network is over 1,500 kilometers. Spread area is the total surface of the city of Milan is a completely interconnected network with 3 degrees of pipes, secondary network, main network, and finally our wastewater treatment plant at the end of the network. The average age is about 66 years. So the first purpose of monitoring is stability detection for health and safety of citizens, obviously. These are the total sizes of our pipe used in sewage network. So you can see we start from little pipes with sides, surface less than 1 square meter of the section, to very big collectors with a section characterized by surface between 3 and 20 square meters. So very big collectors with an extension and volume like gallery for train or tube, for example. So a problem, collapse of this kind of infrastructure, a structural problem, could become a real risk for safety of and stability of the road over this infrastructure. For example, these photos shows some examples of what we have under our feet in Milan. So very big collector, very big infrastructure, and the challenge is a continuous monitoring and stability monitoring of this kind of construction. We put in the field digital solution, obviously. So we monitoring constantly with the IoT systems, flows, level, etc. We know exactly the topographic of and the shape of our network. We put inside also optical fiber to collect other data. We cover about 10 kilometers of the, so a little bit kilometer respect the total of kilometer of sewage network covered by fiber optic. And how to monitor? It's not sufficient only to put inside a discrete point of measurement. Also with digital solution, we need also to put our technician inside and by walk inspect the big collectors. But the problem is we have over 1,500 kilometers. We can walk and inspect each year about 30 kilometers. So with this solution, it's necessary about 50 years to complete the monitor of the sewage network, also using a risk map to put the man or technician in the most in the pipes with the higher risk. And with satellites, what we want to obtain? We want to obtain a continuous monitoring of the all the surface all the surface over Milan and detect each change in terms of depth of the terrain over our collectors. Because subsidence phenomena could be related with an instability and structural problem of our infrastructure. This is what the real danger that we want to contrast with this kind of solution. So a sinkhole that reach the road over the infrastructure. The space-based solution we use is showed in this picture. So we use Sentinel-1 and we use interferometric method. We was a pioneer about using this method and this tool for underground urban infrastructure, because typically this method is used for monitoring landslide in the past, for example. So and Planetech is our technology partner, using first time in the past this method to detect also the subsidence in urban context and link these subsidence with the stability of big sewage collectors. Now we use a complete automatic platform, digital platform that detect monthly with continuous update, continuous monthly update the situation of subsidence over the city, and we can detect easily the pipe and the road affected by a displacement of the soil. So in this case, in Piazza della Repubblica, we detect a red alert linked to a specific sewage pipe enhanced in this picture. We collect the data of for man inspection to detect what's the problem and if the subsidence is effectively linked to the structural problem, and we find effectively a structural problem. You can see the problem in this photo. So a fault inside the pipe that drain the terrain over the pipe and cause the subsidence detected by satellite. So it's a structural platform inside our control process. Every day there is a technician that check the situation of the sewage network from satellite data, and we are extending this kind of method also for detect leakage of water works, because obviously subsidence could be caused also for leakage events, and we can find also fault with the water that come inside the wastewater network, but from waterworks network. So we can check both stability infrastructure of wastewater network and leakage from waterwork networks with the same platform and with the same solution. This is all.
So thank you very much, Andrea, for this presentation. And I don't know if there's questions already in the chat, but I do have a couple of questions for you, because I mean, the presentation was really very interesting. And I mean, I see that you said that now this kind of solution is completely integrated into your workflow, and I can see the benefits of basically optimizing certain processes and the deployment of human resources for your company. However, my question is more related to the motivation. So why a public entity like Metropolitana Milanese decided to turn into satellite-based solutions? So which were the motivations at the beginning, and how you get in touch with Planetech in this case, but also with I mean, with the in general terms, the provider, the service provider? Andrea, can you hear me?
Now I can hear you, but I have a problem with the connection, but I think now it's okay. Well,
yeah, I was just
I can't hear the previous comment. Sorry.
I was just mentioning that I would be very interested in understanding a little bit the motivations. So
Okay.
basically, why Metropolitana Milanese decided to turn and to look into satellite-based solutions, and how you discovered basically about, in this case, Planetech, but in general terms about the service provider, which could give you like this kind of information.
Yes, all started as a trial about 7 years ago, but now it's a real platform with proved solution and proved results. So we are
Great.
satisfied.
So it's
But
good to
really
hear that
satisfied.
it was, I mean, I see that we have also some people from Planetech, maybe Vincenzo is also here with us, but it's nice to hear that it was indeed like a co-design process. So you engaged with them into validating certain data, and
Exactly.
it was co-design process. And I wanted also to say, because you mentioned that currently is indeed completely integrated into your workflow. So I was wondering like whether you have internally some skills, some technical stuff that can indeed like deal with those data, or if you had any challenge in the integration of this with your workflow.
No, this solution works well if the technician can detect directly in the field and it's a validation problem. So if we have technician that could be validate the data from satellite, I can send positive feedback to the satellite technology provider and generate a a good feedback and improve continuously the solution and the technical solution. Yeah.
So I have also one question from the chat, but maybe this is more like let's say I will invite also like Planetech people to open the mic in case they want to reply to this, if they want to complement the answer from Andrea. So the question is like, would you need a higher refresh rate of situation on subsidence? Less than 1 month is, for example, 1 week more useful for you, or even less?
I think is a technology limit in terms of revolution satellite duration. So Sentinel-1, it's over Milan once in a month. So this is the limit. Obviously, weekly refresh could be better, but nowadays it's impossible, I think. But I ask to Planetech if there are other solutions.
So apparently, Luca Soli is saying that they are building like a eye revisit constellation. So there will be like technology advancement soon.
Yes, I'm Vincenzo. So I would like just to add something about this. In general, the service that we provide is let's say is tailored as Andrea explained during the time, according to the needs of the end user and their operational activities. So also the refresh, keeping count let's say the operational frequencies when the operator are available to perform the inspection. So for example, to have a daily update or a weekly update could be too much because it does not complete the cycle of the check on field. So the current update that is monthly that we are providing is adequate according to the operational procedures that we put it in place with Metropolitana Milanese. So it's a question of operational more than technology.
So what I understand is that sometimes revisit time, it's indeed needs to be calibrated also on the operational needs of the user that you have in front. Anyways, I thank you very much. We do have also another question, and it's, I mean, have you noticed, for instance, an interest from other Italian regions to apply the same solution? And I believe that this question is again for both of you.
Yes, obviously many utilities was interested at our solution since the first time of trial, and for example, in Emilia-Romagna, HERA are using the same solution. Through Vincenzo? Yes.
Yes, absolutely.
Yes, correct. Andrea played a fundamental role in the also dissemination of this application throughout all the other operators in Italy. And as he said, he had a pioneer role in this, and is still on the edge of this new application and further integration of with ancillary data.
And I believe that this application is quite agnostic in the sense that it's not only tailored on Milano, but it can be scaled up to any other city in Europe, I guess, or even in the world.
Yes, of course. Yes, of course.
Of course.
Okay, so thank you very much. Also, I invite you to stay with us if you can. So maybe later, if there's any other question, we can come back to you. Thank you very much for this interesting use case. Thank you. And I move now to our next speaker, who is coming from a service provider perspective. So we wanted to have this dual, let's say, angle. And today with us, we have Enrico Schiesaro, who is the Market Development Manager of Cosmi Water Leaks. So Enrico, I invite you, here we go, to switch on your camera. And also on this side, Enrico will tell us a little bit more about the solution that Cosmi Water Leaks developed under, and that they won with this solution. Also, like the ANISA competition, startup competition, couple of years ago, and it's basically to identify water leakages on any type of pipeline and distribution grid. So I will not, describe it myself. Enrico, please, share your screen, and the floor is yours.
Okay, good morning, everyone. You should see my screen now.
Perfectly, thank you.
Okay, good morning, and thank you for the opportunity to introduce you the new and experimental technology for water leak detections using cosmic rays analysis. Let's see how the technology works. First of all, I would like to tell you that Cosmic is a spin-off of Neptunes that deals with the analysis of satellite images for the pre-localizations of water leaks. Okay, we know that the problem of water leaks is worldwide, and it's unthinkable to solve the problem by replacing the entire water network. The main method for searching water leaks is phone acoustic, where two specialized operators, step by step, listen to the noise. This technology, although effective, is limited to control between 5 and 7 kilometers per day. Another technique is satellite pre-localizations, where the soil moisture near the pipelines is revealed through image analysis. The system is able to increase the amount of network analyzed from 5 to 30 kilometers more or less per day. However, it suffers from canyoning effect in larger city centers, which is why we created the new technologies. But let's see what are cosmic rays. Cosmic rays are particles of space origins, and they are divided into high energy primaries and secondaries with low energy, which occurs when they pass through the atmosphere. In particular, neutrons derived from secondary cosmic rays have a strong interaction with hydrogen in water, which stops them from traveling. We need more or less 18 collisions with hydrogen to completely stop a neutron. And what you see is the inverse proportionality relationship between content-free neutrons and soil moisture. This is the first prototype we developed, and we use it to carry out the first feasibility test and to demonstrate the goodness of the principles applied. As you can see, the lithium-6 probe is quite small in size, but large enough to carry out the initial tests. This is the system architecture of the instruments, and here we have used a smartphone as the machine interface, and the sensor represented is the new lithium-6 probe. So this is the structure of the second prototype, and you can see how the size have definitely increased from the previous one. But the sensor is called a scintillator, and let's see how a scintillator works. When a neutron passes through the probe via a photocathode, a light pulse is generated, which is multiplied by a photomultiplier, and the pulses are counted by the electronics. And so the instruments works on the contrary. When the neutron count falls down, we are probably in the presence of a water leak because the soil moisture is increased. And the solutions consist in installing the instruments in a car to map water leaks in dynamic mode at a speed of 40 kilometers per hour, not 50, 40. And this is how it works when a leak is found by the instruments. The real-time solutions make a sort of noise not to distract the driver, so make a sort of drone, and the pilot just stop the car and take the instruments and confirm the leak. The second prototype you can see in the left pictures it was tested at a walking speed and has given the first result in the field. And as you can see, although some counts have been lost due to electronic problem, where there is loss, where you see the red dot, the neutron drop is visible, and the dot become all red. And now we pass to the new instruments with installations on the vehicle and the test conducted at low speed. But this is a video of the solution, how it works, and so with the real-time neutron counting. Here you can see the van is approaching a leak. We have to use a leak in a hole, of course, because you can see and the neutron graph is dropping. Then when the operator moves, the neutron count is going up. And here you can see the water leaks. Those are our customer who have already tested the technology. The first one was Grupo Hira. And now we move from the north to the south of Italy. And we check all condition, all type of pipelines, city center, countryside, from the mountain to the seaside. We have two different type of proposal, but for now the technology is not completely developed. So the thing we can propose now to our customer is the full services. That goes from the data acquisitions to data analysis to the field localizations. We are in this day completely finishing the third prototype that sees another neutron probe that is even bigger than the one you've seen before. The only difference is that the first prototype we want to create, we want that we can move with the instruments even on a trolley or even on a bag. The new probe is quite heavier, and so the only solutions we are now proposing is with the car pre-localizations, or we have the small prototype for countryside or mountain or area where the car can travel. We are now collecting the information at a speed of 40 kilometers per hour. To do that, we have to increase from the first prototype that makes 5 counts per second. The new prototype makes 200 counts per second. This is the other solution I was telling before. This is slow, but in addition to the leaks that can be found with the electroacoustic search, it's also possible to find leaks that are not audible from the operating organs. This is a comparison of the two methodologies we applied in the territories of Grupo ERA, where we have two types of different contracts, one for systematic localization of water leaks and one for testing the solution of cosmic water leaks. And as you can see from the data, more or less we can find the same quantity of leaks in systematic mode or in cosmic mode. These are the development and new application we want to do is install the instruments on board of waste tracker for daily and capillary mapping, where there are people that produce garbage, they even use the water. So more or less, the waste tracker make the same road of the pipelines. And this is all. Thank you.
Thank you very much, Enrico. I think I had a little issue with my connection, but it should be restored. So again, here as well, I mean, thank you very much for this very interesting presentation, for this very innovative, let's say, solution that you're presenting here. I'm going to have a look and to ask, of course, Margherita as well to support me in looking at the questions in the chat.
At the moment, Annalisa, no, I don't see any questions from my side.
Great. So maybe I will ask you something that I was actually thinking during the presentation. So I see that you have indeed like a great and innovative service here, but I wanted to understand whether you face any issue with the commercialization of this service, if there is any, which kind of obstacle, and what do you believe as a service provider is the most difficult indeed obstacle or challenge to the commercialization of the service itself?
Well, really introducing new technology is not that easy, but as I've seen in the presentation, Cosmix is a spin-off of Neptunes, and Neptunes have a commercial network since 2015. So the first things we use is the commercial network of Cosmix. And one thing we can guarantee to the customer is the results, because even if they are trying an experimental technologies, we have all the value chain inside our business activity. So even if we encounter some problems with the technology, we can guarantee the success of the text using other technologies. This has never happened because really the technology works. Sometimes we lost the data, maybe we had some problems with the first type of electronics, so we have to do twice the road we scheduled, but this is not a real problem because in a day we can cover more or less 80 kilometers of pipelines.
So is this like the main, let's say, user and customer that you are targeting for this, let's say, service are institutional customers, I guess?
Yeah, our main customers are water manager or water utility.
Yes.
Such as Metropolitana Milanese, of course.
But is they like...
It's really interesting, I confirm. And then I have a question.
Thank you.
No, please, Andrea, go for it.
Okay. Yes, the question is possible to highlight the main anomaly, because also as we explained previously, the one constraint is our technician ability to detect on the field the anomaly. So it's very important for us
restrict the field of the anomaly and detect the bigger anomaly. So this is the question: how to detect the bigger anomaly respect to the total of anomaly finding?
Well, the real thing is that the instruments analyze the soil moisture content. So it's not possible in this moment to discriminate if we are in presence of a big leak or a small leak. So for now, maybe, I mean, it's easier to find a small leak that is transcurated by the instruments you have to measure your network leakage. In this case, we are not able to discriminate what kind of water we are looking for. So maybe we can find some leak of wastewater, but we are not able to confirm it. And of course, we need our technicians to stop and to localize the water leaks with the electroacoustical instruments. And only in this case, we are able, more or less, to discriminate the importance of the leak.
Okay, I understand. Thank you.
The precision of the instrument is 3 meters of radius. So the localizations is quite fast because you have to analyze just 6 meters of pipelines.
Well, thank you very much.
You're welcome.
So I don't see other questions for you, Enrico, at the moment. So I will, I thank you again, and I will ask you to kindly stay with us for like any further question later on. And I will move to the last but most definitely not least presentation from another service provider. So today we have a shared presentation between Ms. Giulia Tessari and Damien Brachet. I hope I'm pronouncing correctly your surname. Working as remote sensing specialists for SARMAP, and today they will present operational Sentinel-1 monitoring system for water facility in Hungary. So I guess that Giulia will start. So Giulia, the floor is yours. I invite you also to share your screen and to start the presentation. Thank you very much.
Yes, hello. Yes, I will start. Thank you, Giulia. Hello, good morning, everyone. And thank you, Annalisa and Margarita, to give us the opportunity to present today. So I am today with Giulia, remote sensing specialist at SARMAP, our SAR partner. And we will present today an operational use case based on satellite Earth observation data. Next slide, Giulia. So after a short introduction, I will let Giulia present this nationwide services developed for the Hungarian Minister of Agriculture. But first, let me introduce my company. So L3 Harris is providing software and services for more than 40 years. Our image processing software, ENVI, offer to our customer easy-to-use solution to ingest, visualize, and process any kind of Earth observation data, satellite, aerial, UAV, and even mobile. However, we are not only delivering software on disk, but end-to-end solution to answer to specific industry need, like water infrastructure management. Next slide. Next slide. So ENVI Sarscape, an ENVI extension developed by SARMAP, is a complete solution dedicated to SAR processing. It can generate any kind of SAR product, like, for example, digital elevation model or deformation map. It's also include easy-to-use workflow that helps non-expert user to take benefit of this data. And it can also be used in programming mode to deploy operational SAR services on the cloud. As an example, the service that will be presented by Julia is based on SARscape, in which SARmap offers the data exploitation and also the implementation of the service that can be run by the customer itself. I let you the floor, Julia. Thank you.
Okay, thank you, Damien. So I'm briefly introduce you the case that and the service we implemented. So as for the case of Metropolitana of Milan, we were also exploiting Sentinel-1 SAR data, so the freely available Copernicus data that actually provide a really important opportunity of running operational services thanks to their really wide coverage and the dense revisiting time, the frequent revisiting time. So specifically, the use of this data and the exploitation of INSAR application and INSAR algorithms allowed retrieving really small displacement and also to analyze the temporal evolution of this displacement. The study area is actually all Hungary, but among the state, only roughly 70 sites have been selected. So mainly the big problem for who is managing the water facilities and water infrastructure is the present aging of this water management infrastructure. And so the monitoring is increasingly becoming critical as timing is passing since they have been constructed. So as you can see from this, the map of the country, these facilities are really spread around the country, and monitoring with traditional technique obviously is time consuming and also expensive. So what you see in this map are, as I said, all the sites that have been monitored, and in particular, the red points are the one where the condition of the infrastructure and the vegetation land cover were not allowing the technique to be efficient. So in these cases, in these red spots that you see, specifically, there was an installation of corner reflector to make sure that the monitor was effective, even in, let's say, in the wrong condition to apply the technique itself. I will show you more details about this soon. So I'm not spending many words about the technique that is actually the same that has been applied in the first case you saw. So we are exploiting the capability of measuring small deformation thanks to these satellites that are flying over the same areas over time. And we are able to detect a small fraction of the variation of the signal backscatter. Among the available technique in this case, we decided to apply the persistent scatterers algorithm. That is, let's say, the technique that is more focused on a strong reflector and targets with a stable backscatter signal. And as said, we are sensitive to really small deformations. So with this multi-temporal technique, we are able to retrieve deformation in the order of magnitude, let's say, reaching a sensitivity of 2 millimeters per year. Here I show you some example of the first, let's say, how the service started. There was a sort of baseline, so an historical analysis of all the available data over the 70 sites to see if they were actually detectable or not with the technique. So it was considered detectable, a site where at least 5 or more PS points, more than 5 targets were visible. So this is one case of one of the 70 infrastructure. There were cases where no points were visible. So as you can see from these pictures, the main issue was the vegetation somehow masking the infrastructure. And there were other cases where a limited number of points was visible, something between 0 and 5 points. So in this case, the site was considered as improvable. So there was a first classification to see the applicability of the technique over all the 70 sites, these sites to manage, as said, water. And once this first stage was completed, it was decided where to install corner reflectors. So corner reflectors look like this. In this case, they were designed to be used for Sentinel. So depending on the sensor, they can have a different size and different orientation. You see there are couples, so there were 2 of them for each site, at least 2 of them for each point that wanted to be monitored. So in this way, we could catch the signal from both ascending and descending datasets. So we were using all the available data over the area. And here is an example of this dam where you can see how the reflectivity of the signal is showing this, let's say, white square pixel that is representing how strong the signal is reflected by the target. Before and after the installation. So you saw that before the installation, both for ascending and descending dataset, we could only see the overflow drain, so this small point here. But to monitor the stability of the dam, this was not enough. So after installing 3 couples of corner reflectors over the dam, we could start seeing some targets that are the ones that are monitored specifically for this site. And here is an example of the points that were obtained. So the analysis of the deformation over this corner reflector that have been installed. So as you can see, we could see the evolution over time of deformation. These plots are showing, in this case, a stable house or a small building here, while you see the compaction that is characterizing this dam. So for sure, it was necessary to understand that and to make sure that all the sites were visible. So once this was completed, and so the first historical analysis was done, obviously the analysis has been updated. So the strategy to implement the processing and the service that is actually running automatically was, as said, starting with an initial analysis. So using all the available historical data for ascending and descending the dataset. These results are providing a line of sight deformation, so we don't know exactly the direction of deformation. So we were combining the ascending and descending results to retrieve vertical and horizontal deformation for each of the analyzed sites. And then the incremental approach, so the strategy used to update the results of the deformation was every time a new scene was available for the ascending dataset was updated and then recombined with the descending, so reprojected. Same for the descending, so every time a scene was available, the corresponding dataset was updated and the combination was updated. So in this case, it means as Sentinel is providing a new scene over Europe at least when the project started every 6 days. Now one of the 2 satellites is not operational, so every 12 days. So at least initially every 6 days, now every 12 days, 2 scenes are available, one for the ascending and one for the descending. It means the system is updating the results at least twice every 12 days right now. All the results that have been generated and are generated from this automatic workflow that is ingesting any new scene every time is available for all the 70 sites is then used to somehow tune and define another system. So up to now, the process is fully running automatically. We are in a validation stage because obviously setting warning system and alert system is something even more delicate. So there is no fixed threshold for everything. It depends from the kind of infrastructure and from the aging. And so up to now, they are somehow doing some leveling and quality control and validation of the results, also to help tuning this alert system that should then help the final user, that is going to be the Minister of Agriculture and Minister of Water of Hungary, that will automatically see this interactive interface where obviously they can do queries and visualize the time series of the formation, but also alerts will be automatically shown. So obviously the technician of the ministers probably don't have time to plot all the points. So any anomalies will be highlighted automatically in this interface that is already in their hands. So if you want more details about the implemented service, there is also a scientific article about what has been done and how all the automatization, and also from the hardware point of view and processing point of view, there are more details. And obviously, in the previous case, I was mainly focused on infrastructures, but this application of measuring deformation affecting infrastructure can obviously also be applied to linear features that can be a pipeline, or as it was for the case of Metropolitana of Milan. So this was another service implemented in Tuscany to monitor how deformation could affect pipelines. So it's not about leakages, but it's just about how deformation can be somehow triggered by leakages of pipelines, or deformation due to landslides can trigger, somehow can change the stress condition of a pipeline itself, so it can cause a possible risk. So just to conclude, the brief presentation was mainly showing this automatic system that actually was optimized, so installing corner reflector, as we were not working in a urban environment where somehow we know the technique is really effective, while in open fields it's not always working, so we needed to install some dedicated corner reflectors. And these frequent updates that is automatic every new incoming image is somehow trying to provide an almost near real-time processing capability. Obviously, the revisiting time of the satellite is a constraint, so it's not going to be a real time in terms of processing as soon a new image is available, but the update, as said, is somehow weekly. And yeah, with this I concluded. So
thank you very much, Julia and Damien as well, for this, again, like very interesting service. We are running a little bit out of time, but I do have a question for you, because, well, first of all, you said that this is also like having this warning system, and which is indeed like also something that was mentioned by Andrea before, which is a very key component of this kind of solution. And I saw that you have a sort of dashboard that you will provide to the people, let's say, working at the ministry, because I guess that they won't have a technical background as you do. So I was wondering whether you do provide them also with training, info sessions. So how do you accompany the process of uptake of this kind of information? Because we saw a lot of graphs, indicators, stats, and sometimes this is not necessarily understandable by people that, or let's say the information stemming from these kind of things are difficult to understand if you don't have a technical background. So I just was wondering what you do.
So, okay, I can take the question. So mainly, first of all, as it was for the previous case, even what is shown in the dashboard is something customized. So I need to be tailored on the customer requirements, and not every application needs the same parameters to be visualized. And obviously, yes, let's say that this is the most delicate thing. So make sure that the service is really useful. So for sure, we train the customer in case they were requesting just the ready to visualize solutions, so just the final results. As Damien was saying, let's say our training spectrum is wider, because eventually we can even train people on building their own system. So we provide the software, we provide the tools, and they can even, if they have more technical people that want to be involved, they can even learn how to do that on their own. As I said, the customer could be, I mean, this case was a service, but we also provide software and teach people how to process data. So depending on the requirements and the level and how people want to be involved in the data processing or not, we are fully flexible in this case.
Oh, great. So indeed, it's actually also like the service that you kind of provide is tailored on the needs and on the competencies of the customers. This is also like
it's really important that the final user is part of the project, is really active, as otherwise he's not going to use what we provide.
This is indeed also like what we experience in working with users. And my next question would be like, do you believe that one day for this kind of services, we will have like something off the shelves, like something which is indeed like a standardized service? And in this case, I also like take into, I mean, I extend the question also to the other speakers from a more service provider point of view.
Okay.
Yes.
Please.
No, I can just say that in fact, for us, it's always very easy, always very difficult to propose this type of services. And currently we are working a lot to try to understand the need of our customer, and we are working closely with them to try to develop, I would say, some proof of concept, and to closely work with them to understand very well the need and to build the system step by step. And so, and in fact, as Julia said before, I think for us it's very important to be, I would say, a software provider. So it means that we can help the customer to understand very well the technology, to see to them what he can obtain and how we can go. So on my side, I speak, I would say, on the as a software provider company, but maybe Julia, you can add something more on the services itself.
Yeah, regarding a standardization, I think as now there are a lot of services and country scale, like even the European ground motion service that somehow was processing the information all over Europe. They define standard in terms of density of points and capability of measurements, quality check with GPS. While I think when you work on dedicated application, depending on the user, they have different requirements. So I think there are some things that need to be standardized, like the format of the data, how they are visualized. Obviously, there are different software, different algorithms, and anyone somehow customize a bit. So sometimes the customer want the customization, while for large scale services, there are some standards for mainly in terms of quality and capability of the technique. Yeah, I think it's not really, I mean, I think there is still some variation. Who is in the field that can easily read different format, but maybe the final user can be a bit confused. Yes.
Thank you very much. I don't know if there's other questions. I see none at the moment. So unless Margherita, you want to add something, I think I will.
Nothing from my side, just to thank also the speakers for their participation and their presentation, and that we will resume next year. But I leave you doing the closing remarks. Thank you.
Yes. Indeed, also on my side, I want to thank all the speakers for being with us and for those very, very interesting presentations. I remember to all the participants that the recordings and the short summary of this session will be shared with everybody and will be published in the website of our two organizations. So you have plenty of ways to communicate about this, and also like to get to see again what we've been discussing today. Our next session of the Space for Critical Infrastructure webinar, as Margherita mentioned, will be held on 2023. So it's, let's say, we will reconvene the session in next year, and it's going to be about digital infrastructure and health. So also another very interesting and key topic. And I invite everybody to follow us and to indeed like engage with us with comments or with anything else through our website. Thank you very much, and have a nice day, everybody. Bye-bye.
Thank you. Bye-bye.
Bye-bye.